This is a question from electrochemistry, a direct question. The standard cell potential of the following cell. The cell is represented Zn, Zn2 plus aqueous, then Fe2 plus aqueous bar Fe in is 0.32 volt. That is the standard cell potential. Now calculate the standard Gibbs energy change for the reaction Zn solid plus Fe2 plus aqueous giving Zn2 plus aqueous plus Fe solid. Given 1 Faraday equals 96,487 coulomb per mole. So here we are given the data given to us is the cell reaction. Then its standard cell potential. We are asked to find the standard Gibbs energy change for the reaction. Now the standard Gibbs energy change is given or represented as delta G naught, and standard cell potential E naught is given as 0.32 volt. Now the relation between standard Gibbs free energy change delta naught and standard cell potential E naught is like this. Delta G naught equals minus NF E naught, where N is the number of moles of electrons transferred in the reaction. And 1 Faraday is given as 96,487 coulomb per mole. So let us write this reaction. That is zinc Zn solid plus Fe2 plus aqueous giving Zn2 plus aqueous plus Fe solid. So here we can see that zinc is losing 2 electrons and it is becoming Zn2 plus. And who is gaining those 2 electrons? Fe2 plus is gaining those 2 electrons and it is becoming Fe solid. So the number of moles of electrons transferred in the reaction, that is N equals 2 in this reaction. Now it is simple because delta G naught, that is the standard Gibbs free energy change, equals minus N into Faraday into E naught. E naught is, what was E naught? Standard cell potential, which is given to us as 0.32 volt. So let us calculate the delta G naught equals minus 2 into Faraday is 96,487 coulomb per mole into E naught is 0.32. When we do the calculation, we will get the answer as 61751.68. But none of these answers match it. Because this is given in kilojoule per mole. So we have to convert this into kilojoules by dividing it by 1000. And dividing it by 1000, we will get 61.75. We can write it as, so the negative sign is there, minus 61.75 kilojoule per mole or mole inverse. So the first option, option A, is minus 61.75 kilojoule per mole. That is the correct answer. Now another thing is that this is a feasible reaction because E naught, when E naught is less or E naught is greater than 0 and delta G naught is less than 0. Here E naught is 0.32, which is greater than 0, and delta G naught is less than 0 because we are getting it as minus 61.75 kilojoule per mole. So it is a thermodynamically feasible reaction.